Hello, good morning everyone. Today we are going to see software testing unit 19. In the previous topic we have started with the concept non-functional testing and we have studied what is non-functional testing and scalability testing, which is a type of non-functional testing. In today's topic we'll see the another type of non-functional testing, that is reliability testing. So in reliability testing we check out whether the system keeps on operating for a long time without the failure. For example, now suppose you are testing 10,000 login times for 20 hours. So within 20 hours, 10,000 login times will operate properly or no without failures. So for how much long time for particular operation the system keeps on working without failures, that will be tested in a reliability testing. Because there are sudden changes in the system, because sometimes due to a high load the system crashes. So this should not happen. So in a case of high load the system should not crash and should keep on operating. So that will be tested here. Reliability test measure the ability of the system to keep operating for a long time or for a large number of iterations without developing failures. This testing is used to calculate the probability of failure for a particular function. So in this testing you are also going to find out what is the probability of failure for a particular function. Like login time function, if you keep on logging 10,000 times, till how much time it will occur a failure. So you can calculate the probability of failure of a login time function. So in which case it fails and how much hours it keeps on operating. Examples of reliability include like querying database continuously for 48 hours and performing login operations 10,000 times. See now, in a database you are going to store login times, that is login operation 10,000 times for 48 hours. So at least your objective is that within 48 hours the login operation should support 10,000 login times. So should not fail within this 48 hours. Even if the login operation is carried out 10,000 times, should not fail in this case, should keep on operating at least for 48 hours. After 48 hours, if it fails, then we'll understand what is the probability of failing the login operation for specific time. So to make sure system can be operated for longer duration without developing failures. So in a reliability testing, the main objective is that system can be operated for longer duration without developing failures. So reliability of a product and reliability testing is different. Both are not similar. Reliability of the product and reliability testing both are different. So reliability testing you already seen. You are going to test specifically there for how much long hours the system keeps on operating without failures. Now this reliability of a product have some process, like say defined engineering process. So these are some steps which will prove that it is a reliability of a product, means product is reliable. Defined engineering process, that is software reliability can be achieved by following clearly defined process. So you need to define clearly what exactly the process is. Next is review of work products at each stage. So at the end of each stage of the product development life cycle, each work products produced are reviewed. So as I told you, the products will be having different units and modules, components. So what each component is doing and how it has developed, and the review of all these modules, components will be collected here at each stage, will be reviewed exactly what has happened there. Change management procedures. Many errors get into the product due to improper impact analysis of changes made to the product. So changes received late during the product development life cycle can prove harmful, means those can be harmful. So some of the errors get into the product due to the changing some features or some working, so which is going to also impact on the working product. Next is review of test coverage. So what are the tests you have performed? It is the review of that, how many test cases are passed, or that is how many tests are successful, how many tests are failed, and what type of defects are available in that. So this review report. Next is ongoing monitoring of the product. So once the product has been delivered, it is analyzed properly for any possibly missed errors. So ongoing monitoring of the product is when the user is working on that, it will be monitored properly to check out whether all functions are working properly and it has not missed any possibly some errors. So reliability testing is actually used to measure, to define a component's or reliability, system's reliability, that is to find the difference between mean time between the failures, and that is mean time between failure is calculated by the equation like total time elapsed minus sum of downtime divided by number of failures. So in reliability testing, you are going to measure, you are going to calculate how much time it has taken and at what time the failure has occurred and how many number of failures has occurred. So that time will be measured here. Next we'll see stress testing. So in a stress testing, it is actually the breaking of a system to find out the point at which point the system breaks or the system fails. So that point is identified, so that we'll understand what is the capacity of the system, till how much load it can handle and at which point the system breaks. So this testing is conducted to check out at what point your system breaks and fails. So stress testing helps in understanding how the system can behave under insufficient memory, inadequate hardware and realistic situations. So it is actually the breaking of a system. So to break the system, you are going to increase the load of the system, and if the load of the system increases, then obviously there is going to be insufficient memory, inadequate hardware working and realistic situations. So which part it is going to affect the system? Which part of the system it is going to affect memory, hardware or any other? It involves testing beyond normal operational capacity, often to a breaking point, in order to observe the result. Normally these are related to synchronization issues, memory leaks or race condition, etc. So normally due to this breaking of a system, it is actually going to give the synchronization problems or memory issues or the race condition, etc. Example of stress testing. So in banking application, a banking application can take a maximum user load of 20,000 concurrent users. So a bank application can take maximum user load of 20,000 concurrent users. So the capacity of that application banking is 20,000 users. It can support 20,000 users. But to check the breaking point of the system, how this test is carried out, the load will be increased to 21,000 users and do some transactions like deposit or withdraw. So the load will be increased to 21,000 users and you're going to check the functions of the system like deposit or withdraw. So are the user is able to make successful deposit transaction or withdraw transaction. As soon as you did the transaction, banking application server database will sync with ATM database server. So banking application database will be synced with ATM database server. So that will be updated in the ATM database server also. Now check with the user load of 21,000. Does this sync has happened successfully or no? So you're going to check as the banking application will be linked to ATM and the syncing must be proper, updation should be proper and all. Deposit transaction updation and withdrawal transaction updation should be successful. You're going to check that. If it is successful, then now repeat the same with the other load, that is just increase it with 22,000 users and repeat the same, and now check out how the system is behaving. So this is how the trace testing is carried out to find out the breaking point of the system and how the system can handle that. Here load is increased by increasing the number of clients, transactions till and beyond the transactions are completely utilized. See, so all the functions of that system will be performed so that the load can increase, and how the system is handling that. Difference lies in the way tests are run. Product reaches a trace point and load is reduced to recover. Yes. So it is a little similar like scalability testing, but in a scalability testing, you're going to find out what is the capacity of the system. That means it has one objective, that in scalability testing it has one objective that at least 20,000 users the system must support. So only that part it will be tested there. So only till 20,000 users can your system support. So till that much it will be scalable. Now in this trace testing you are going to find out that breaking point specifically, and after reaching that breaking point, can your system recover again? Can your system recover again? So to recover your system you are going to reduce the load. So if you reduce the load, check out whether your system is behaving in the same manner or no. So this is the difference lies between scalability testing and trace testing. So the time required for the product to quickly recover from those failures is represented by mean time to recover. So in this point you are also going to find out the breaking point as well as can the system recover from those failures. Even that will be tested here. Some guidelines can be used to select the test for trace testing. So repetitive tests, so which are repeated many times, that you are going to test, like login time is repeated many times, deposit transaction. So such type of repetitive test cases you can select and you can repeat it. Concurrency, you are going to perform it multiple times so that the load can increase. Magnitude, the amount of load to be applied to the product to trace the system. So magnitude is you are going to find out how much load you are going to load on the system, you are going to increase on the system. Random variation, you are going to check out, you are going to analyze the variations. Like say trace testing depends on increasing or decreasing variable load. So test the system with random inputs. So you are going to observe this, you are going to analyze this. What is happening when you are increasing the load, and after the reaching the breaking point, decrease the load and check out what is happening, how the system is behaving. Trace testing helps to determine errors in slowness, any security loopholes with overloads, as if you increase the overload. So if there are memory leaks or any security loopholes in the system, that will be detected. How the hardware reacts with overloads, and data corruption issues of overload. Sometimes what happens, if the data is overloaded, some of the data will be corrupted or not stored in the database, will be missed out, lost. So this will be all detected if you perform trace testing. Next, interoperability testing. So in this interoperability testing is, you're going to check out the exchange of information between two softwares. So sometimes the situation arises where you need to take the help of other software product. So the software product which you have developed can be linked with other software product. For example, to make the online transactions, so you have to link your software product with a banking application page so that the online transaction can happen. So how is the information between these two softwares? and how the communication is happening, whether the transaction is successful or no. So that will be tested here. Or it can be also any hardware components. Okay, like for example, your software product is using the biometric device. So whether that biometric device is able to detect the input and able to give the output or no, and whether it is able to process or no, this will be tested. So this is interoperability testing, when you're taking the help of other devices, software components or hardware components or software product. So the exchange of information between these products you are going to test. Interoperability means the capability of the software to interact with other systems or software components. Another definition, interoperability testing is done to ensure the two or more products can exchange information, use information and work properly together. Some guidelines that help in improving interoperability. So these are the points which you need to keep in mind when you are testing this between the two softwares or components. Consistency of information flow across systems. So how is the information is flowing across these systems that you are going to test. Changes to data representation as per the system requirements. Yes, when you are going to link the two systems, two softwares, then the information which flows from one software to another software will be different. The data which is represented will be different. Now your software, the data representation in your software is different, whereas the data represented in another software is different. So when the information is going from your system to another system, so the data representation must be changed according to that other system. When the information is flowing from your system to another system, so representation must be changed according to that other system, so that it can understand what type of input is coming and what output should be given. Correlated interchange of messages and receiving appropriate responses, as even the messages which are sent from one system to another system, the message format and the response, even this has to be tested and should able to understand each other's systems. Communication and messages. Communication, how is the messages are going, flow is going from one system to another system or from components. Meeting quality factors. So you should also keep in mind that the quality is maintained whenever the two systems are linked and information is flowing from one system to another system. It should not affect the quality. The response should be fast, or other factors also should be considered. Not all types of tests are applicable to all projects, but depends on nature and scope of the project. So till now, whatever the functional testing and non-functional testing methods we have studied, it's not possible, or it may not need that all types of testing you need to conduct. So it is based on the project and the requirements, based on and situation. Based on this, you can think which type of testing you can apply on the software product. Load testing or performance testing. So load testing is also called as performance testing. So the main goal of load testing is to identify the upper limit of the system. So how you can increase the load on the system. So to increase the load on the system, there are many ways. Running multiple applications on the computer, simultaneously starting with one application and then start second another application, then third, and so on. Now see the performance of your system. This is how you're going to increase the load on the system. Start performing all the functions of that system, so that obviously the load increases on the system, and with this load, how the performance of your system, how is the system is behaving, whether the performance is the same or the performance has reduced, it has become slow. So this all will be tested in the load testing. So here we have finished non-functional testing. In the next topic, we'll see with a new topic. Thank you.